Good morning, students. Today we will be learning how to balance complex chemical equations algebraically. Okay, students, let's begin. This is the chemical equation we will be working with today. First, let's establish a systematic way to balance this chemical equation using letters as coefficients. I've gone ahead and assigned each compound a letter coefficient. Utilizing these coefficients, we will create an algebraic equation for every element in order to balance the chemical equation. For example, there is one atom of hydrogen in hydrogen chloride and 2 atoms of hydrogen in water on the reactant side. There are also 3 atoms of hydrogen in arsenic acid on the product side. Since the coefficients on each respective compound are A, D, and F, the resulting equation will be A plus 2D equals 3F. Using the same approach, we can create the following algebraic equations for each element present in the chemical equation. For chlorine, the chemical equation will be A equals G. For arsenic, it will be 2B equals F. For sodium, C equals G. For nitrogen, C equals E. And finally, for oxygen, 3B plus 3C plus D equals E plus 4F. In order to begin solving the algebraic equations, we must establish one of the coefficients as 1. You can choose any of the coefficients because stoichiometric coefficients are relative values. For the purpose of this problem, we will establish B as equal to 1. Plugging B equals 1 into arsenic's algebraic equation, we find F is equal to 2. Based on the equations for chlorine, sodium, and nitrogen, we see that A equals G, G equals C, C equals E. In order to move forward, we will set these coefficients as X. Now let's solve for D by inserting the value we have found for F as well as the established X value into the algebraic equation for hydrogen. Using basic algebra, we find that D equals 3 minus 0.5x. Next, solve for X. In order to solve for X, you must input your D value, F value, and B values into the equation and convert C and E to X. We find that X is equal to 4 over 3. After solving for X, you can input the found X value back into the D equals 3 minus 0.5x. This gives you the final answer for D, which is 7 over 3. Now we have found values for each coefficient. Find the lowest whole number coefficient. In this case, we will multiply each coefficient by 3. Now we can replace our letter coefficients with our newly solved values. The last step is checking that the equation is balanced, and indeed it is. Now you should be able to balance any complex chemical equation using algebra. Good luck!